Okay, this is a problem for physics grade 11 at James M. Hill. There's 5 types of force questions that we need to be able to work with and answer that we're going to do in class. And so I'm going to go through those throughout the next kind of 5 videos. So we'll start with number 1 from your assignment that you were assigned. A 25 kilogram crate is pulled at a constant velocity with an applied force of 125 newtons. So remember, when you're reading a question, read it once and then read it again and start picking out forces that you know. 25 kilogram crate. 25 kilograms is not a force, but with mass we can get force of gravity. So just a little note, maybe to remind yourself that 25 kilograms is not the force of gravity, but we can calculate the force of gravity if needed. Constant velocity, that's important. Constant velocity tells us that our net force is 0 newtons. And an applied force of 125, so we know what the applied force is. A, calculate the force of friction. Looking through your equations, the best bet for finding the force of friction, given net force and force applied, is to use the definition of net force. So net force equals the sum of all the forces in the same dimension, okay, so in the same x direction or in the east-west direction. So for me, in this problem, the net force is going to equal the force of friction plus the force applied. Doesn't matter which order you write force of friction or force applied. So I know the net force is 0. I'm trying to solve for the force of friction, and I know my applied force is 125. Rearranging for the force of friction, negative 125. So that should make sense. If your net force is 0, then there has to be a force of friction equal but in opposite direction to our applied force of 125. For B, calculate the normal force on the crate. For us in grade 11, the normal force can always be calculated by calculating the force of gravity. They're going to be equal. We're not going to do problems where the normal force will change. Be aware it can be different, but we're going to keep it simple at first so we get the hang of how this works. So the normal force is equal to mass times the acceleration of gravity, because force of gravity is mass times the acceleration due to gravity. So there's where the 25 comes in, and 9.81 for our gravity, and that gets you 245 newtons. There we go, 245. And that's an upward direction if we needed that information from the ground. Last one, C, calculate the coefficient of kinetic friction. There's only one formula with coefficient of kinetic friction right in it, and that's the force of friction equals the coefficient times the normal force. Rearranging, that's going to be coefficient equals the force of friction divided by the normal force. Force of friction is 125. Normal force is 245. So you probably notice I didn't write negative 125. In this relationship, we're just using magnitudes. So if you want, I can emphasize that we're just using magnitudes by putting absolute value signs around those forces. After that, calculate it, and you should get 0.51. So there's no units for force of friction.